So why do we need inverse? We can solve the system of equation using matrices. So here, if you have 2, 3, 1, 3 times x and y, what do? You sandwich it. So multiply 2 with x, you get 2x plus 5 times 3. Y times 3. It's 2x plus 3y equals to 6. And when you do the second row, it becomes x plus 3y equals to 9. This is system of equation. 3x plus 3y equals to 6. 1x plus 3y equals to 9. How can we solve it? You can solve it the way you've been doing, or you can use the matrix. How? Just look at the coefficient matrix, and you find the inverse of it. And then when you multiply the inverse to these answers, it becomes x and y. So from here, you're solving for x and y, right? How do we undo this matrix? We can make this 1 by multiplying the inverse, right? So if you multiply the inverse, 2, 3, 1, 3, and the notation for inverse is like -1 power, then what does this become? Identity, right? 1. So then that gives you x and y. But what do you need to do if you do multiply by this inverse on one side? You have to multiply the inverse on the other side too. And if you do that, you can find the x and y. So it's like this. If you want to find the answer, you do the inverse of the coefficient matrix. Like this. If you multiply the inverse to x and y, then you get these two, which is your x and y. So let's try it. So here, let's rewrite these in matrices. How do you write this in matrix? Coefficient matrix will be 3, -2, -1, 4. Make sure the x's are first and y. If they switch x and y, then you have to rearrange them. Times what? xy becomes what? 7, 11. Oh, 7, 11. So then what do we need to do? Find its inverse and multiply by 7, 11. So how do you find the inverse? Let's say this is C. C, inverse of C is what? 1 over the determinant. What's the determinant? This times, multiply this, minus that. So 3 times 4 is 12, minus 2. So 10 is determinant, right? Not 1 over 10. 10 is the determinant. Times, what do we do with 3 and 4? You switch. What do you do with these two? Make them opposite. So negative becomes positive. Negative becomes positive. So this becomes what? 1 over 10. Oh, yeah, 1. So it's 1 over 10 times those. This is 1. So it's 4, 2, 1, 3. So basically, what are you doing? You multiply by 0.1 to all 4. So you get 0.4, 0.2, 0.1, 0.3. That's inverse of this matrix. And what do you need to do to solve for x and y? To solve for x and y, what do? You multiply the inverse, 0.4, 0.2, 0.1, 0.3 with 7, 11. Now you sandwich them, right? So you multiply the first row with first column. So 7 times 0.4 is 0.28 or 2.8. 2.8. right? And 11 times 0.2 is 2.2. You add them. Now with the second row, first column, 7 times 0.1 is 0.7. 11 times 0.3 is 3.3. So when you add them, you get 5 and 4. So your x is 5, y is 4. So what do we have to do? We have to put these two matrices, right? And let's find the inverse and multiply by that. So go to second matrix again. Edit. This time 2 by 2 and 3, -2. Let's put this matrix. -1 and 4. Second matrix, edit. For B, let's put 2 by 1, 7, 11. 7, 11. So let's check our inverse matrix first, okay? So quit, clear everything. Second matrix, A, and just find the inverse. Oh, you see where this our inverse is? Inverse. And now what do? You multiply that inverse with what? 7, 11, which was second matrix, B. Right? I'm just carrying this over. It is 5, 4. Did we get 5, 4? Yes.